I would define feed efficiency as the ability of an animal to convert feed into a useful product, whether that's meat or milk or eggs or what have you. And the reason it's important is that any production system, and this is a peculiar thing, it doesn't matter if we're talking about extensive or intensive livestock or cattle production or ruminant production or monogastrics, the cost of production, the major cost of any production system is feed.
Hello, everyone. Welcome to this episode of the Feed Science Podcast Show, brought to you on behalf of Wise Genetics. I am Wilmer Pacheco. I am an associate professor in the Department of Poultry Science at Auburn University. We are dedicated to bringing you the latest insights and the discussions in the feed industry. Get ready to expand your knowledge and stay ahead with today's episode. And today we are honored to be joined by Dr. Roberto Sainz, Professor Emeritus from the University of California, with decades of experience in animal biology, systems modeling, and sustainable livestock production. Dr. Sainz has been leading voice bridging genetics, nutrition, and efficiency. And in this episode, we will dive into the genetics of feed efficiency and environmental sustainability of beef cattle, what it means, how we measure it, and where the future is heading. Hello, Dr. Sainz. How are you doing?
Hello, Wilmer, and hello to everybody watching here.
And Dr. Sainz, could you introduce yourself to our audience?
Sure. My name is Roberto Sainz. I'm, as Wilmer said, a professor emeritus at the UC Davis. I retired in 2018 after about 30 years working there. Prior to that, I worked a couple of years about 4 years in Australia at the University of Melbourne, and before that in New Zealand for the National Research Advisory Council. So it's a pleasure and an honor to be here with you.
Well, I'm sure that experience in Australia and New Zealand was a great experience. I have never been in that part of the world yet.
Well, they're both very wonderful countries, very beautiful. Obviously, a very vibrant animal production sector. Very valuable experience.
Excellent. Well, let's start with the basics, Dr. Sainz. How would you define feed efficiency in livestock, and why is such a critical trait in modern cattle production systems?
Well, there are multiple dimensions to that question. First of all, I would define feed efficiency as the ability of an animal to convert feed into a useful product, whether that's meat or milk or eggs or what have you. And the reason it's important is that any production system, and this is a peculiar thing, it doesn't matter if we're talking about extensive or intensive livestock or cattle production or ruminant production or monogastrics, the cost of production, the major cost of any production system is feed. So, we talk a lot about the profitability and sustainability of livestock production. And the first aspect of sustainability, of course, is economic sustainability. So in order to maintain a viable industry, it has to be, first of all, economically sustainable. So the livestock producer is generally a price taker. In other words, we can't just raise the price of our meat or eggs or whatever the product is, depending on the production cost, right? We have to take whatever the market will bear, and so the profit equation, of course, is the difference between income and expenses. The only thing that the producer has control over are the expenses. Has no control over the prices. Very little control over prices. And so controlling the cost of production means controlling the cost of feed and minimizing that to the maximum degree possible, And if we can improve the efficiency with which animals convert that into product, then we are making a positive contribution. There are also environmental concerns, right? All livestock produce waste. And in the case of ruminants, we are under a lot of scrutiny, increasing scrutiny, in terms of emission of greenhouse gases, particularly methane. And that's a product of enteric fermentation. So it just makes sense that animals that consume less, ferment less, will produce less methane. And we have very interesting data about that as well.
Yeah, that's very important because you are looking at from a different angles. In your opinion, how our understanding of the genetic basics for feed efficiency has evolved over the last 2 decades?
Well, quite a bit. If you'll permit me to tell a little story, um, I came from Australia to UC Davis as a faculty member, assistant professor, in 1991, and I was doing some research at the time regarding the metabolism of animal that were with beef cattle of energy utilization in these animals, and particularly the effects of limit feeding or feeding a restricted amount of feed, and also compensatory growth. And I think because of that work, in 1995, Fred Owens set up a symposium at Oklahoma dealing with all aspects of feed intake and performance and this kind of thing. And Fred had a nasty habit. He would set up a symposium and put out a program and a list of speakers. He wouldn't invite you to speak. He would just announce that you were going to be at the symposium presenting the topic that he chose. And so I found that's just the way Fred operated. Anyway, I found myself on the program dealing with what makes limit-fed animals more efficient. And at the time, remember, I only had 3 years at Davis. I didn't have an immense amount of data and knowledge about it. And so I found myself to say, well, what do I do now? So what I did was I took what I knew or thought I knew about metabolism and physiology and digestion and made a list of hypotheses about why an animal might be more efficient than another in terms of feed conversion, feed efficiency. And so that list included things like, maybe perhaps one animal is better at digesting feed than another. So that was an obvious thing to do. If an animal can extract more nutrients from the same feed, it stands to reason it would be more productive. And then also metabolic aspects, things like protein metabolism and protein turnover, things like that, things like body composition. We know that it's more efficient energetically to deposit lean tissue and muscle than it is to deposit fat. And so perhaps differences in body composition would explain that effect. Anyway, I made a long list of hypotheses, and I modeled the potential contribution of each of these mechanisms to the animal's efficiency. Well, that was the reason I tell this story is because that kind of directed the rest of my career for the next 25 years, because what I wound up doing was I wound up testing these hypotheses one by one over the next 25 years and doing the experiments and publishing the results. Well, it's funny how science can work that way. And, I think the general public has a distorted view of science and scientists. We're all human beings, right? We're all trying to make our way through this life. And sometimes one event can kind of change your direction and put you on that path. And so I spent the next 25 years studying each of these things, the digestibility, the metabolism, the body composition. And the last dissertation that I supervised when I was on faculty at Davis was we finally got down to the point where we were looking at mitochondrial function in animals with their higher or lower feed efficiency. And we found that yes, there are in fact differences in the leakage of protons across the inner mitochondrial membrane, and that could explain a very large part of the differences in feed efficiency. In other words, when you have leakage of protons, of course, that means that the proton gradient that's been generated through all of metabolism uh, that affects how efficiently those protons can turn into ATP. So it turns out that more efficient animals are better able to convert that proton gradient into ATP than less efficient animals.
Excellent. Yeah. Very interesting. And like another one, I think that you have been studying a lot is residual feed intake, which could be used as a measure. What are the advantages and limitations of using a residual feed intake in genetic selection programs?
Well, the standard measure of feed efficiency, we talk about confinement feeding, right? Intensive production is feed conversion. In other words, how many kilos of feed it takes to generate a kilo of gain, or pounds, if you prefer, it doesn't matter. And that turns out to not be a very good measure for genetic selection. And the reason is, as I alluded, the composition of gain can have a major impact in that conversion ratio. In other words, leaner animals will tend to have a better conversion than animals that are depositing fat. Well, when is an animal leanest? When it's very young, right? And the composition changes from lean to fat as the animal matures. Well, if you select simply on feed conversion, what you wind up getting is an animal that is physiologically younger and therefore leaner. Well, at the same weight, if you have an animal that's physiologically younger, that means that its mature size is going to increase, right? So when you select on feed conversion, you wind up selecting animals that are larger at maturity, and that has all sorts of implications for the efficiency of the overall production system. The larger animal has a higher maintenance requirement, higher feed requirement, and the poultry people have done this very intensively. Of course, the genetic gains in poultry are very rapid, right? Because of high fertility rate and a short generation interval. And so, as you well know, then the breeders for broilers, for example, have a very high mature weight. If we're killing animals at 3.5 kilos, 4 kilos, their parents are at maturity are maybe 20 kilos or more. And so that works for poultry. It's a disaster. It'd be a disaster in the cattle industry. And so residual feed intake is different because what it is the difference between what we'd expect the animal to eat and what it actually ate. Okay, the as the Brazilians would say, pulo do gato, right? The trick here is that how do you define what the animal is supposed to eat, or the expected intake, right? As we know, a growing animal requires energy for two main purposes: one for maintenance, and the second for growth. And so the residual feed intake equation takes account of the animal's metabolic weight, that is weight to the 3/4 power, and the rate of gain. Okay, and so by taking account of that, you eliminate these effects on mature size, and that's what makes it so useful for genetic selection.
That's really interesting. And when you are balancing feed efficiency, how you also balance other economically important traits like growth rates, like reproduction or meat quality.
We've published many studies on this, and in fact, a lot of the research that I did a lot of it at Davis in California, but also a lot in Brazil. And we have many thousands of data points to work with. You know, animal breeders love to have very large data sets. And when we do these studies, of course, with the cooperating herds, they measure everything, right? So we're contemplating simultaneously the fertility, the sexual precocity of the animals, the carcass quality, the even in many cases the meat quality. So I think in any production system, the number one characteristic that a breeder will select for is fertility, because without that, none of the rest matters, right? And so you never do selection for a single trait. You do selection for a wide range of traits. And so by doing that, then you can avoid any kinds of unexpected or undesirable genetic correlations, right? As a matter of fact, we have not found any negative genetic correlations with things like carcass characteristics like subcutaneous fat or marbling or ribeye area, and also not found any adverse effects on reproduction when we look at RFI.
It's time for our famous three.
Genetics turns podcast airtime into brand authority. We don't sell ads, we elevate voices. Curious how far your voice can go to become a reference in the industry and attract more leads? Scan the QR code and discover how we can turn your expertise into unmatched brand authority. Let's transform expertise into influence, starting now.
And Dr. Sainz, last year you published a paper where you evaluated correlation between maintenance and genetics. Could you please share the findings of this paper?
Certainly. After all those years studying the physiological underpinnings of differences in feed efficiency, we've concluded that the main difference nutritionally between more efficient and less efficient animals is their maintenance requirement. Of course, just like everything else, before you can do anything else, you have to make sure the animal can survive, and that's it. That's what it needs for maintenance. And so we had that physiological understanding, nutritional understanding, but we really didn't have a handle on the genetics of that. We've been selecting for feed efficiency for many years. And so what we did is we took all of those data. If I know what the animal ate and what the energy content of the diet is and what it deposited in the body, which I know because we estimate body composition using ultrasound, then I can calculate the energy budget for all of those animals and how much they allocated towards maintenance. Maintenance is one of those funny things. It's you can't measure it in a producing animal, right? It has a maintenance requirement. Only God knows what it is. And so we did that estimation and then ran it through the algorithms for genetic evaluation. And what we found then is that the maintenance requirement has a heritability in Nelore cattle of about 19%. Okay, so it's not a high heritability, but it is a solid one.
And have you also evaluated genetics and methane production as well?
Well, after those decades of research looking at the nutritional and physiological underpinnings of the differences in feed efficiency, we reached a conclusion that the thing that's different between highly efficient and poorly efficient animals is the maintenance requirement. The animal needs a certain amount of energy and nutrients just to survive and to maintain itself. And so that gets paid first before there's any nutrients left over for production, for growth, or anything else. And so we took the performance data we had from more than 5,000 animals of Nelore breed in Brazil. And if I know the composition of the diet, I know how much energy is available, I know what the animal deposited, because we monitor body composition through ultrasound, then I can calculate an energy budget for each individual and how much energy was allocated towards maintenance for those animals. So we did that calculation, then subjected those data to the standard genetic evaluations, and we found that the maintenance requirement by itself as an isolated characteristic has a heritability of about 0.19. And what that means then is that it can be selected for, and you can make genetic progress to reduce the maintenance requirement of the animals.
Well, that concludes another episode of the Fit Science Podcast Show presented by Genetics. Thank you for joining us today. Don't forget to subscribe to stay updated on future episodes. And if you enjoy today's episode, please leave us a comment. Thanks, Dr. Sainz, and I hope everyone have a blessed day.